Okay, this is for 1.7 in the book, your page 72 homework. This page is in your book. Our goals this week is to be able to talk about how the transformation of a graph is changed by the numbers put into the parent function. So we're going to talk about vertical and horizontal shifts and sketch graphs of them. We're also going to use reflections about the X and Y axis and be able to sketch those. And that's going to be the main gig we have. If you look down here at the bottom of this page, you should have learned that if you add some constant to the function you're starting with, if you add a c, that's going to move the whole graph up, which is called a vertical shift, because vertical's up and down. A vertical shift up, whatever that c value is, up that many units. So if that was a 3, it would move everything up 3. So if I look at this problem, x squared is the parent graph. We got an x squared and then plus 2. That moved this vertex up 2. It moved this point that was at 1, 1 up to 1, 3. It moved this point that was a negative 1, 1 up to negative 1, 3. So it takes every point and moves them up 3. If you have a negative number out there all by itself, that's going to move the whole thing down. So if this was minus 2, this thing would have moved down to negative 2, and that would have been your vertex. And 1, 1 would have moved down to 1, negative 1. And negative 1, 1 would have moved down to negative 1, negative 1. And you would have had the parabola move down. Every point would have been moved down 2 places from the original. Then when you have a variable that's, or a number that is inside the parentheses with the x, this gives you horizontal shifts. Now what the main thing you got to look here is, that if you have a minus sign, it moves the graph right. If you have a plus sign, it moves the graph left. So I always say if it's a horizontal shift, it moves opposite of the sign. So if I look up here at the x squared graph, the same graph as the parent graph here, and now they put the minus 2 inside the parentheses. It goes with the x. If you look at this one, there was a plus 2 not with the x. So the parentheses tell you that the minus 2 is with it. So this is a horizontal shift, and since that's a minus 2, it took this vertex and it moved it over 1, 2 places. It took the point 1, 1 here and it moved it over 1, 2 places to there. It took the negative 1 and it moved it over 1, 2 places to there. And every point on this original graph would be moved right 2 places because of the minus 2 with the x. And hopefully you were getting that from your transformations worksheet. Reflections happen this way. If you have a negative in front of the whole thing, this was the y value, now they're saying a negative y value, that flips it over the x-axis. That's called a reflection across the x-axis. So if you look at this graph right here that's opening up, if you put a negative, this is again x squared, if you put a negative in front, it takes all the points and it moves them down. So 0, 0, there is no negative 0, so it stays right where it is. The 1, 1 graph, the 1, 1 point becomes 1, negative 1. It makes the y value negative. The negative 1, 1 point becomes negative 1, negative 1. So it flips it upside down, flips the original function upside down. If you put a negative inside with the x, that reflects it across the y-axis. So this one's kind of weird because on this graph, if you have 1, 1, that would change 1, 1 over to negative 1, 1. And the negative 1, 1 would flip over to here. So this would actually be the identical same graph because it's already symmetric to the y-axis. But we're going to do some more examples later of that kind of problem. And there's examples here that you can look at that might help you. Okay, so these are your homework problems. So you need to do these. I know number 9 is your first one. I was going to highlight these and then I forgot to. So these are more homework problems here. I know that you're doing 2 problems that aren't on this sheet. You're doing 62 and 70 something. That one of them is a story problem. I want you to give the best shot you can. Okay, I think we stop at 52 down here. That's not really very well on the graph. I guess I can move it down and you can see it there. You're going to do 52. Some of the other things we're going to do is by giving the graphs, you're going to have to write equations for these things. And I'm going to do some of those examples. So this is actually number 9 from the book. And you're supposed to use the graph of f. This is the graph of f right here. See that little f right there? And you're supposed to sketch all of these graphs. So what I'm going to do is I'm not going to do them all because I don't have enough different colors, but I'm going to do some of these. So you see this graph right here? So this negative is with the x. That means you're going to reflect across the x-axis. So I'm going to draw it right here where it is. So this 6, because now there's a negative there, this 6 becomes negative 6. So I would come over here to negative 6, and the 2 would not change. So this one right here, 6, 2, reflects over here to negative 6, 2. This negative 4, 2, the negative 4 changes sign because it's a negative 4. So that reflects over here to 4, 2. And then this graph, 0, negative 2. Well, you can't have a negative 0, so it's going to stay right there because you can't make 0 negative, so it does nothing. And then this negative 2, a negative 2 is positive 2, so it reflects over here to 2, negative 2. So then if I connect these dots, that would be this first function. And I guess I will do them all because I can erase this and do each one individually. Now that is called, this function is called a reflection over the y-axis or across the y-axis. So all these things flip across the y. Okay, we're going to do b now. So I'm going to erase this. This is like that first problem I did. There's a +4 out here all by itself. So this is a vertical shift up 4 units because the 4 is by itself. So I come down here and I take this point at negative 4, 2, and I move it up 1, 2, 3, 4. So now it becomes negative 4, 6. So if you look, I'm adding 4 to that 2. Negative 2, negative 2. I'm down here at this y of negative 2. So I'm going to go up 1, 2, 3, 4. And again, if I add 4 to negative 2, that gives me 2. So this point is negative 2, 2. This point goes up 4. 1, 2, 3, 4. So it becomes 0, 2. This point goes up 4. 1, 2, 3, 4. So it becomes 6, 6. And now all I got to do is connect the lines. Oh, I missed that one. That wasn't very straight. And that right there would be the vertical shift up 4. I'm going to do this next one. There's a 2 in front of f of x. That means we're doubling all the y's. So we got to double the y values. The x's aren't affected. This thing is called a vertical stretch. I'm going to put vertical stretch. And I say times 2 because we're doubling the y's. So this negative 4, 2 means I have to double that y because f of x is y. So 2 times 2 is 4. So this point becomes negative 4, 4. Then I come down here and I have to double this negative 2. So negative 2 times 2 is negative 4. So this is going to be negative 2, negative 4. I got to double this negative 2, which is negative 4. So it becomes 0, negative 4. And then I have to double that 2. So this becomes 6, 4. So if I draw this thing, hopefully that helps you see why it's called a stretch, because it takes that original graph and it stretches it vertically, makes it more vertical because it doubles the y values. Okay, this one is a little trickier because there's 2 things going on. I'm going to erase this one. 2 things going on. One thing that's different is we have a minus. We got a -4 inside. So that is a horizontal shift. And you got to write the word shift and stretch because they both start with an S. Right, because horizontal shifts are opposite of the sign. So right 4. And then this negative sign, that negative sign means that it is reflected or reflects across the x-axis. So that's going to flip it upside down when we're done. So what I'm going to do is I'm going to first of all move this point right 4. So I'm going to go right 1, 2, 3, 4. And then I have to make it a negative value. So since that's positive 2, it flips it down here to negative 2. So this is going to be the point 10, negative 2. So again, this minus 4 moved it right 4. That's why I went out to 10. And then that negative flips it upside down. So it goes down to negative 2. We're going to do this point. We're going to move it right. 1, 2, 3, 4. And then I have to flip this sign from negative 2 to positive 2. So that's going to move it up to 4, 2. So this is going to be 4, 2. Again, it moved right to 4 because of that moved it right 4 and that flipped it upside down. That was a negative 2, which is why it's positive 2. We're going to take this point, move it right 4. 1, 2, 3, 4, and then we multiply the negative 2 by negative 1, which is positive 2. So that's going to move that thing right here, and that point would be 2, 2. And then we're going to move this point right 4. So I go right 1, 2, 3, 4, and then I got to change the sign of the 2 to negative 2. So that flips it down right here. So that point becomes this point, 0, negative 2. And then I connect these dots best I can in straight lines, which I can't do very well with this thing for some reason. Didn't have that point very well. So this would be the transformation by those two things. So next problem. This one only has one transformation. It's got a negative 3 all by itself. So this is a vertical shift. It's not a stretch, it's a shift. And because it's negative 3, it's down 3. So I got to move this point down 3. 1, 2, 3. Oh, wait a minute, that's only 2. I can't count. Let me move it down 3. So it's a 2, 2, 1, 2, 3. So it's going to be down here at negative 4, negative 1. Then I'm going to take this point down 1, 2, 3. So it's going to come down here at negative 2, negative 5. Probably need to move it over here a little more. This one comes down 1, 2, 3. So this is at 0, negative 5. And this point comes down 3. 1, 2, 3. So it's at 6, negative 1. And again, you just connect the dots and you are done. I should call them the dots. I should call it points. So that would be number E. F again, I'm going to erase. F again has two things. This, do you see this negative 1's by itself? So this part is a vertical shift down 1, and then we're supposed to take the y and flip it over. So we're actually going to do, because order of operations say multiply before you add and subtract, and this is subtracting, we're going to multiply by negative 1, which is going to reflect over the x-axis. So I'm going to take this point and I'm going to multiply this 2 by negative 1. So that's going to make me down here at negative 4, negative 2. But because it's got a minus 1, I've got to go down another dot. Then this point, I got to multiply this by negative 1. So I'm going to go up to 2, but I've got to go minus 1 because it also shifts it down 1. I've got to take this negative 2 times negative 1, which shifts it up here to 2. And then that minus 1 out there is going to shift it down 1. And then this 2 I take times negative 1, which is going to come down here to negative 2. But I got a minus 1 on top of that, so that's going to shift it down to negative 3. I put the wrong ordered pair for that one, my bad. 0, 1. And then I connect these dots, and that's what the transformation looks like. We got one more. We got one now where the 2 is doubled inside. So because the 2 is inside, we call that a horizontal stretch. Times 2. So this means whatever the x value is, we're now going to double the x value because the 2's with the x. So this says 6, 2. So when I double 6, that is going to move me out to 12, 2. Let's say there, tick mark, 12. Now you're going to see why it's called a horizontal stretch. When I take this times 2, it's still 0. So this does nothing. This point is still right there. When I take that negative 2 times 2, that becomes negative 4, 2. So it becomes over here at negative 4. Negative 4, 2. And then when I take that times 2, that comes out to, let's see, 6, 7, 8. Negative 8, 2. So when I connect this, I hope you see that that makes it look wider. And that's because we had a horizontal stretch, because it's multiplying the x by a number greater than 1. Now, something I want to point out to you is if that number right there was between 0 and 1, like a half, that would make it a vertical shrink, or sorry, horizontal shrink. It would make these x's half, and it'd bring everything closer together in here. If this number in front of the y up here was like a half, it was between 0 and 1, that would be a vertical shrink. So it would not go up as high, go up half as high and down half as low. So that is problem 9, which is going to help us with all the problems. I'm going to try to do the rest of these a little quicker here. So let's see, we're supposed to, can't see this very well. I think we're supposed to write the equation for the function. So if we don't know it, the parent function for this is that right there. So I'm going to do this problem first. The original function has these points in it. It's a positive 1 slope that way and a negative 1 slope this way. So if you look at this point, I go up 1 over 1, and up 1 over 1 that way. My slope hadn't changed. I have moved this graph over this way and down this way. So if you look at this graph, I have a horizontal shift right 2, and I have a vertical shift down 4. So I take this original function, and I know that horizontal shifts go with the x. So inside there with the x, I'm going right 2, and horizontal shifts are the opposite. I have to put -2 because I'm going right 2. I know vertical shifts are the same direction, and since down is negative, out here, not in there with the x, I put a -4, and that's the equation for B. We're going to do this next problem. Again, the original graph goes like this. So now they've taken the vertex and they've moved it over there. So they moved this. This has a horizontal shift left. 1, 2, 3, left 3. And they flipped it upside down. So that is a reflection across or over the x-axis. So the horizontal shift tells me that I'm going to have, because it's going left, negative, I have to put +3. And then to reflect over something, you have to make it negative. So this would be the equation for that one up there. And you can type these into your graphing calculator and see they're correct. I'm going to go on. I'm going to do 17 and 18, I think. So this is the x squared graph, which normally goes like this. And we actually had this in the example earlier. It's flipped upside down, so all 17 is going to be as f of x, or you can do y as negative x squared, flips it over. Now let's look at this one. This could be 2 different answers. I could say the original step function goes like this. Hope you remember that from class. So there's 2 things that could have happened here. I could have moved this a horizontal over 1, 2, 3, 4. So if I did a horizontal left 4, I could have written that with the double brackets, x plus 4, like that, and that would work. That'd be the right answer. Well, another thing I could have said was, hey, this goes up 1, 2, 3, 4. It goes up 4. So I could also say that it's the regular old x1 by itself if I say it got moved up 4 and put a plus 4 like this. If you graph these two things on the same graphing calculator, it will put the same graph on top of each other. So either one of these will count right. You don't have to put them both down. You just have to do one of those. All right, let's see what we got next. All right, and this is another one here. Square root function, x squared. So if you can't tell, this graph's been moved down 2, 4. Wait a minute, it's going. I can't read those numbers. I'm gonna look over here. They're going by twos. 2, 4, 6, 8. Who do we appreciate? So it looks like to me, that number right there would be -7. So it's been moved down 7 and left 1. So left 1 is a horizontal shift, and left means we got to put +1 in with the x. Down 7 means -7. Now this one's a crazy one here because the vertex has been moved right 3 and down -4. So it's been moved right 3 down -4. So what that means is the right 3 is x minus 3 in there. Come on, pen. X minus 3 is in there. And then I got a -4 way out here. But then if you look at this, it's been, and these normally go like this. But this is going upside down. So because this is going upside down, I got to put a negative out here. And then it's flipped across the y-axis the other way. So I got to put parentheses around this and make this part in here negative as well. So this is kind of a tricky one here. All right, I'm going to erase this, and we're going to do this one over here. This 38 says we're supposed to name the parent function. So by now you should know 2 lines mean that the parent function is the absolute value function. And now we want to describe the transformations. Well, the original absolute value function looks like this. So I want to look up here, how many things have changed? Well, this is one thing that's changed right there. Here's another thing that's changed. The 2 in front has changed. The negative sign in front has changed. So there are 4 things that are different up here from this graph. So I'm supposed to tell all 4 of those. So it doesn't matter where I start. So I can start with that negative. So the negative up there reflects over the x-axis. The 2 in front is a vertical stretch times 2. The +1 in there is with the x, so that is a horizontal shift. Remember, horizontals are opposites, so it's +1. So that means left 1. And then this -3 out here by itself, those are vertical shifts. And minus is down, so a vertical shift down 3. And now I'm supposed to sketch this thing. So what I'm going to do here is I'm going to let's go, first of all, let's look at the original graph. So the original graph of absolute value is of the slope of 1 that way, slope of -1 that way. So my new vertex is going to be 1 left and down 3. So I'm going to go 1 left and go down 1, 2, 3 and put a dot. That's my new vertical shift. Okay, so I can put my vertex right there. Now that would be the same as if, well, actually I have to do more than that because of the 2 out here. So like if I put 0 in here, this is 0 plus 1 is 1. Absolute value of 1 is 1 times negative 2 is negative 2 minus 3. So if I put 0 in there, that's going to, I guess that's not the new vertex anyway. That's going to be down here at negative 5. If I had the 0 in there, like if I put negative 1 in there, this whole thing's 0 and it is negative 3. So it is left 1 and down 3 like I just said. That's your new vertex. This is the next point over. Notice these are normally going up 1 over 1, up 1 over 1, but because of that negative 2, I now have to go down 2 over 1. So I can also go down 2 and over 1 this way. And this graph is going to be a V upside down because of the negative in front. That flips it over the x-axis, and that graph would look like that. We are not going to do the D part, so don't worry about that. Let's see what else we got here. 39. It says the shape of f of x squared is the function we're dealing with. We're going to write the equation described by this. So it says shifted 3 units to the right. So that's horizontal shift. So what that tells me is I can use y. I'm going to say g of x. It doesn't matter. So I'm going to have in parentheses, now this says right, so I got to do the opposite of positive, which is negative 3. I got to put that with the x and square it, and then it says 7 units down. So I stick a minus 7 on there, and that's the equation we're looking for right there. So you're going to be, we already did some of those earlier from a picture. 47, this I think, I got one more after this, I think. Writing equations from graphs using the fx x squared. So these are both x squared graphs, but they're a little different than they were before. So I want to talk about the x squared function, which I hope you know it by now, because you did it a whole bunch already, but I'm going to draw the original function right here. 0, 0 is on the graph. 1, 1 is on the graph. Negative 1, 1 is on the graph. The first points are normally up 1 over 1. Then the next points are up 3. 1, 2, 3 from this point, up 3 and over 1. The next one would go up 5 and over 1. The next odd number higher is how far you go up when you do quadratics. So this is kind of what this graph looks like. So I'm going to do this graph first. So it looks like to me the original graph, the original vertex is here, but they moved it up 1, 2, 3. So I know right now that I've got an x squared and I'm going up 3. Now it did not move right or left, so I don't need any parentheses there because the vertex didn't go right or left, it just went up 3. Now the next thing is really weird. Normally we go up 1 over 1. Well, that one value is the one value that is right here. That's where that 1 goes. That up 1 over 1 is that 1. But we are going up 1, 2, actually, we're going up to 7. So we're going up 1, 2, 3, 4 and over 1. So our first move up is 4, which makes this a vertical stretch times 4. So this would be that equation. And we got one more here. So this flips upside down. The vertex has not moved at all. It's still on the origin. So I don't have to have anything with the x or out by itself. So I've got a y equals an x squared. And because it's flipped upside down, I have a negative sign here. Now this one, instead of going down 1 over 1, I'm going down 1, 2, 3 over 1 because of that negative 3. So that means I have to have a stretch times 3. So that's not very clear there. It should be y equals negative 3x squared would be the equation for this graph. And we got one last one I'm going to do. Which one is it? Oh, this one up here. It says write the equation for these two functions. So I'm going to do both these and call it a day. And again, I'm going to come over here, and this is the parent function for these, because that's what a square root graph looks like. And the original graph looks like this. There are some points that you should know are on it. 0, 0, 1, 1, And when you do the square root of 4, you get 2. So the normal graph looks like this. You could put 9, 3 if you want. All right, so this graph is going in the same direction as that, but do you see how it's stretched up higher? It's stretched up higher because when we plugged in 4, we get out 16. Over here, when we plugged in 4, we got out 2. So the square root of 4 is 2, right? Square root of 4 is this 2. But we're taking this value of 2 and we're taking it times 8 to get to 16. So this graph is going to be a vertical stretch of 8. So I have to put an 8 out in front of that thing. Now that's pretty hard. If you can't tell it, but 1, 8 would be that point right there if you put a 1 in. You put 4 in there, that's 2 times 8 is that 16. Okay, last one I'm going to do is this, and then you're going to get to try these. So if you look here, and again, they're using the 4, and they're only at -1/2. So this is a vertical shrink. So in other words, the number here has to be less than, this number has to be less than 1, between 0 and 1. And since it's flipped upside down, it's reflected over x, it's going to make the whole thing negative. So we're going to have y equals a negative. Now, I guess kind of the question is, we know we normally get 4, 2. What would you have to do to 2? What would you divide 2 by to get to -1/2? And the answer is -4, or -1/4. If you divide 2 by 4, that's that half. So this would be the equation right here. So if I stuck this 1 in here, that ordered pair right there would be 1 and -1/4. So that's what you're doing for homework, is dealing with transformations for Monday. So I hope you do well, and I will be ready to answer any questions you got. Have a great weekend. I'll see you guys Monday.